Here's the answer for day 1, problem 1. Simplify as much as possible. We have the square root of this expression. 60 is not a perfect square, so let's factor it using a perfect square. We could go 4 times 15. 4 is a perfect square. A squared is a perfect square already, so let's leave that. And b to the 5th power is not a perfect square. Let's factor it as b to the 4th power times b. And then in the next step, any of the factors that are perfect squares we'll take the square root of. That would be the 4, the a squared, and the b to the 4th power. Square root of 4 makes 2. The square root of a squared is a. The square root of b to the 4th power is b to the 2nd power. And then there are a couple factors that we'll leave inside of a square root symbol. The 15 and this b right here. And so here is the simplified form of the original expression. Day 1, problem 2, factor the polynomial. The first kind of factoring to try is to look for a GCF. There is a number that divides into all terms. It is -3. It's customary if the leading coefficient of a polynomial is negative to include a negative sign with the GCF. The variable x will not divide into all terms because the last term does not have an x. So the GCF is only -3. And then we're going to put a set of parentheses and complete the trinomial that would be in there. -3 times x squared creates that first term. -3 times -2x creates that middle term. And -3 times a +4 creates that last term. We now need to check this trinomial and make sure it doesn't factor any further. Numbers that multiply together to make 4 are 1 times 4, or -1 times -4, or 2 times 2, or -2 times -2. None of these pairs of numbers combine together to create -2. And so this trinomial does not factor further, and here is our completely factored form.